Okay, we're letting everyone into our presentation tonight. I'm going to wait till the number gets up where it seems like it's stopped. What do you think? Are we ready to go? Okay, I think we'll get started. Welcome. Welcome. Are we ready? Welcome to the ACE Mentor Program of Washington Student Presentation Night. My name is Angela Gatula. I'm the Executive Director of ACE. For 19 years in our area, the ACE Mentor Program has brought together architects, engineers, construction managers, real estate developers, and more with the goal to raise awareness for high school students to careers in the building industry. The ACE program is a national organization that was started in New York City in 1994. There are currently affiliates all over the country. The Seattle affiliate was started in 2001 and is one of the longest running actually in the country. Our affiliate, again, started in 2001. We expanded to Bellevue in 2006 and Tacoma in 2016. In total, we estimate 3,000 plus students have completed ACE in the Puget Sound area. Our scholarship program is incredible. It's awarded more than $864,000 to seniors pursuing ACE careers, and we plan to award $120,000 to 19 seniors later this month, including several who are on the call tonight. As many of you are aware, this past year or so was unusual to say the least. ACE, like every other program nationwide, had to adapt. This was the first year we did an all virtual ACE program. There's a sort of magic that exists with ACE when students and mentors can gather together shoulder to shoulder, and we hope to return to that next year. But this virtual experience has likely forever changed the program and the entire industry. We look forward to taking all the lessons that we learned and applying them to make the future of ACE better. Also, I wanted to mention that all of the photos, most of the photos that we put in the slideshow tonight are actual screenshots from ACE meetings this year. I was tempted to just use photos from the previous years of, you know, spaghetti and gumdrop structures or, you know, whatever. But I think the ACE teams need to be celebrated for the virtual program that they created. So these are all pictures of you. Okay, so what did this year look like? We had 160 students from 57 area high schools participate in this year's program. They were divided into 11 teams. We say there were 2 East Side teams, 1 Tacoma team, and 8 Seattle teams. But the reality of it is that because of the virtual nature, the students could attend meetings anywhere, regardless of geography. The students were mentored by about 180 of the brightest professionals from 63 of our region's architectural, construction, and engineering firms. At about 4 o'clock this afternoon, I emailed a program to all of the students, the parents, the mentors, and the registrants of this virtual event. In the program, it lists the names of all the students and mentors, and it outlines a bit more about this year's student project. The program also has links to our Facebook and our Instagram pages if you want to check those out and follow us. I want to give a special shout out to all the seniors who are graduating and finishing this year strong. Seniors, in this emailed program that you received, there are special instructions on how to register as an ACE alumni. You'll want to do that so that you receive ACE news, scholarship opportunities, internship and job information, and a lot more. So a little bit about tonight. Over the course of the school year, teams learned about each of the disciplines, and they met sometimes weekly with their mentors to work on a design project in response to a request for proposal. You can see that this outlines the student project for the year, which was a STEAM educational facility built on a Seattle Center site. This RFP was written by our friends at the Seneca Group, a local real estate development firm that served to represent the ownership side all year. Seneca representatives visited the ACE teams, reviewed their concept plans, answered questions. So tonight is sort of like the students' final pitch to the owner to get their design selected. And that's the same thing that happens in real life. So to keep this as real as possible, we actually invited a panel of judges to review the presentations and moderate the Q&A. So I'd like to introduce our panel of judges to you. First, Avra Plattis is a development manager at Seneca Group. If you remember, I mentioned Seneca earlier. Avra led the effort to write this initial RFP document, and so she's here as the final owner representative, and she's definitely the one to impress. She attended several ACE team meetings this year for many of our ACE teams, and she's seen the designs in process, and she's got pretty high expectations for tonight, I think. Second, Dan Alier is also a development manager at Seneca Group, but as an added bonus, Dan used to be an ACE mentor, so he knows exactly the time and the energy that goes into these final presentations and their designs. Dan gets it, and I'm glad he's here to give his input from the owner's perspective and from a mentor's perspective. Lastly, we've invited Leon Holloway. He's joining us tonight as a representative from the design industry. Hi, waves. Leon is a project architect at the DLR Group, and this, I think, is his first ACE event, so let's just knock his socks off. DLR Group is a longtime donor to the ACE Scholarship Program, and Leon is currently the president of the Northwest chapter of the National Organization of Minority Architects. I love Leon's enthusiasm for architecture and diversity, and I can't wait to see what he thinks about tonight. So thank you to these three guest judges for participating. So next, a couple logistics about the call. You can see all of the attendees are muted. Well, there's two different designations. We have attendees and we have panelists. Most people watching the call tonight are attendees, but all of the students and our judges and our mentor leaders are in panelist mode, which means that they can speak and they can turn on their videos, unmute themselves. If you are an attendee and you look at the bottom of your screen, you'll notice you've got two options. There's a chat box, and you're welcome to chat to the panelists and all the attendees as you'd like. Also, there's a Q&A box. As the presentations are going on, if you have any questions that you'd like to ask, pose to the students in the team, you can put questions in the Q&A box, and students can answer them as the presentations continue. At the end of the presentations, our three judges will moderate the question and answer period. You can continue to ask questions. They will pose them to the students, and they'll have questions of their own to share as well. Lastly, students during Q&A, please turn on your camera so we can see you. Also, to all the teams, please stay for both presentations to support each other and be respectful of all the time that everyone has put into this event. And it's a good idea to check out your competition, right? Okay, so let's get started. Our first presentation tonight is Seattle Wednesday Team 1. Well, we would say Seattle, it's really just Wednesday Team 1. I'd like to introduce you to Kayla Verbitsky of GGLO. She is the team leader this year. Kayla has been the team leader of this GGLO team for several years. And she served as a mentor for a couple of years before that. So she's really stepped up to the plate. And I'd like to give her a few minutes to introduce the team, and then we will roll the video. Okay, Kayla.
All right, thanks, Angela. So first off, I just want to give a big shout out to our students this year. It was a challenging year, as Angela has already stated, and they really stepped up to the plate and did a fantastic job. And I'm hoping that you'll all be as pleased with the final result as we were. Second people I'd like to thank are definitely our mentors. We just had some fantastic mentors this year. Like, everyone showed up, I think, every week. So huge shout out to GGLO, CollinsWoerman, Lease, Crutcher Lewis, Coffman Engineers, Arup, and BCQ Structural Engineering. Lastly, just thank you to Angela and the rest of the team at ACE. You guys have a well-oiled machine here, and this is a great program. So definitely happy to see it carrying on. So thanks, everybody.
I am Leo Ruben Stencil. I've been doing ACE for 3 years now. I'm on the interior design team, and this is Wednesday Team 1. We did a STEAM technology classroom and laboratory. The purpose of this building was to create a new STEAM classroom and lab for high school students. The city of Seattle recognized that there's a need for it in the area, so they granted us a piece of land for the facility, as well as a $12 million permit budget for the permit, design, and construction. The requirements for this project were that it would be 10,000 square feet standalone. It would have a technology classroom, a wet lab classroom. It would be completely public, and it would function as a venue for high school students to explore the STEAM subjects. The project guidelines go as follows. It needs to be completed by the 2023 school year. It needs to take into account COVID and COVID restrictions. It needs to fit in with its surroundings for aesthetic purposes, as well as integrate its facility and campus into public landscaping and outdoor features such as gardening and terraces. It needs to make sure to keep into account public transport and biking. So for most students, they will not be able to drive yet due to them being high schoolers, and make sure that they achieve the minimum of the LEED gold and include a prominent design feature that promotes sustainability.
So this project was designed for, well, obviously the students of the school, as well as the teachers engaging in the STEAM program. In addition, any guest professionals, parents, as well as the public that parts of the building were designed for. And obviously this building would need to support, the general teaching and education, the various labs, meeting spaces and classrooms, as well as more niche like experiment rooms and presentation rooms, as well as standard student teacher transportation. And this project is important for the community because it really creates space for the city of Seattle and the high school students within to practice and engage with the community and with the idea of STEAM itself and for related activities.
Hello, my name is Zach Burwell. I'm part of the landscape team. This is my third year doing Lease. Some of our project goals are to create a building that responds to the Space Needle. Want to showcase builds made by the students. We also want like private learning, but the rest of the building is open to the public. Want a space that promotes creativity with students while also keeping a safe environment to prevent COVID-19. Our mission statement is to create an environment to promote STEAM fields to high school students where they can learn and have access to lab spaces and for the community to come and appreciate the surrounding area.
Hi, I'm Aria Grosvia. This is my third year of ACE and I'm part of the interior designs team this year. In the RFP, the project required computer labs, wet labs, digital fabrication labs, and meeting room space. A lobby and exhibit area, as well as break rooms, restrooms, and support spaces like mechanical, electrical, and storage were also required for the facility. Throughout the design process, we added several additional programs to meet our project goals, including educational presentation spaces, a printing lab, a quiet workroom, and an outdoor wet lab terrace. We also included a roof deck garden and an outdoor terrace open to the public.
Hello, my name is Henry, and myself, Anna, and Andy are the architecture group. We have worked to design the exterior as well as the overall mass of our STEAM building. And to start, Anna will be talking through our site plan.
Our site is located on Denny Way and Broad Street in downtown Seattle. Its neighboring buildings, Coma Plaza, the Space Needle, Pacific Science Center, and the Mopop offer great views and heavy foot traffic. Because of this, we've made an effort to have an area and entrance open to the public with more private entrances on the east and south of the building. We have a parking lot just east of the site with sun from the southeast to the southwest daily.
This is a concept rendering of our building in its early design stages. From this view, you can see the ribbon feature as well as the wave design wrapping around certain parts of the exterior, which nods to the surrounding architecture, but doesn't totally steal the show. From here, a few details were added and minor changes were also made, but the overall shape has remained the same through the final design. And this is an overall image of our building facing southwest. From this view, you can partially see the stairs that are encased in glass, which interiors we'll touch on later. The ground floor also includes large windows that provide views towards the attractions surrounding the site.
Okay, this slide is a material and elevation precedent. To start off with, the materials that are gonna be used in our building are concrete, steel, glass, and metal, as well as different composites such as wood and plastic. We have images that acted as reference points as we designed the building. For instance, on the left-hand side, there is an image of a building that possesses a concrete ribbon, similar to the one situated over our building. All right, here we have images and sketches that show parts of the design process we went through while designing facades. On the left, there are 3 rough diagrams showing some concepts of different variations of screen patterns. We have also included some rougher but more developed sketches, which helped us map out where some of the screen and what parts of the building could look like.
In our northeast elevation on the left, you can see our public entrance through our courtyard. Our courtyard features a curved metal screen with cutouts and a steel exterior wave skin on either side, in addition to a 3rd floor terrace and rooftop access. In our northwest elevation, you can see a continuation of our exterior wave skin along with a continuation of our steel screen with cutouts. Our building has a concrete ribbon feature that comes down the elevator shaft and wraps over to the other side of the building. The left shows our southwest elevation with our concrete ribbon feature wrapping over top of our building in a wave-like structure, providing shelter to rooftop users with a 1st floor window and a more private indoor-outdoor connection. And finally, our southern terrace on the 3rd floor. Our southeast elevation shows both our southern and northern 3rd floor terraces that provide a private and more focused learning environment. And our ribbon feature comes down the side of our building along the secondary stairwell.
Here we have a section cut through the middle of the building. There are people in a meeting, learning, or just doing their jobs. In this diagram, we can observe the different learning environments, namely wet labs or digital fabrication. Also, as a way to lessen the impact of COVID-19 on students and facility members, areas may be more spread out than normal. Note that this is just an example of what all the different rooms may look like while populated with people, and it's not concrete.
With sustainability as a priority, we will put in a conscious effort into sourcing our steel, concrete, and lumber locally in a way to minimize our footprint. In addition to sustainable material sourcing, we plan to install a rainwater irrigation system along our ribbon feature, taking Seattle's weather into account.
This final view showcases the building and its beautiful surroundings. In the distance, the Space Needle and Pacific Science Center can be seen, and the MOPOP sits just out of view but still in close proximity. All the learning done in our STEAM building can be built upon and expanded in these other educational facilities. From here, structural has the floor.
We also use the forces shear and moment in our calculations. So a gravity load path is defined as a load coming from the top to bottom of a structure or from its origin down to a structure. So you can see a little diagram of the flow of the loads that's coming down. So what kind of loads are we talking about? Well, we have dead and live load. Dead loads are loads of the weight of the structure, which is like walls, floors, columns. Live loads are the weight of moving objects. So like it's the people, the furniture, and like unconstant variables. So as you can see here, we have made a little gravity design structure for our floors of the building. So levels 1, 2, 3, and the roof. Blue is like the girders, red is the beams, green is the columns, and the yellow is like technically still beams, but it's holding up the canopy for the roof. Down at the bottom left, it's a little illustration of what the forces of shear and moment. There's a uniform force along the beam, which is distributed, and down there is like the shear force. We've also calculated the beam, rivet, and column demand and capacity. Demand is like where like how much they're asking, and the capacity is like how much they can actually hold. All right, moving on to lateral design. Lateral load path is defined as like lateral forces to a building. So like wind forces or earthquake forces being applied through a building. And when we think of lateral design, we would like to associate it with Newton's second law, where the force equals mass times acceleration. The mass is the weight of the building, and the acceleration is the earthquake force being applied through the building. And that multiplied together will equal the seismic force, which is what we calculated for the lateral design. But during this, we also have to consider the geography of Seattle. So we have to consider like the acceleration, which is like the occupancy, the structural system, location, size, or period. Those are just some of the considerations. As you can see here, the lateral design numbers we use to calculate the seismic force. So like example risk category, we had to consider that, and some more numbers too. But that's basically what we used to calculate the seismic force at the end. Moving on to the ribbon, you can see at the picture below, it's like a rough sketch of what the ribbon will look like. Because of its complex wavy design, we have decided to simplify it down to a basic side and roof plan. You can see the red dots are the sample, the attachment points that are attaching the ribbon to the building. And to analyze the ribbon, we have decided to take a sample strip from the attachment points, or like we decided to take a sample strip from the ribbon that spans from one attachment point to the other. During the analyzation of the section, we have checked the sidewall for wind force and checking the roof for gravity and wind forces applying onto that. And as you can see in the little this picture at the bottom, you can see there's steel bars applied into the concrete of the section of the ribbon. That is basically reinforced steel, which is best to help with moment capacity. And that's basically how we analyze the ribbon for architectural component. And that should conclude.
Hello, and welcome to the interior design presentation. My name is Ada, and I work with my peers Leo and Aria, and my mentors Lauren, Kristen, and Sarah.
Here we have the floor plans for level 1. You enter the lobby from the main entrance, where there are seating areas for students and visitors, and in the center, a STEM art installation. As you enter, you can see which run all the way up the building between the two elevators. Off to the left and right are various meeting and presentation spaces, and farther through the lobby are restrooms. At the other end of the building is the break room for staff and the mechanical room, which has glass walls so you can see into the systems as you walk by. The south entrance leads out to the water retention garden. Now for the lobby, the main inspiration was the far left photo for its bright and open feel and seating area configuration, which was also inspired by the far right picture. The circular reception desk image was where our reception desk design idea came from, and the image above incorporates the lobby and feature staircase and how they might interact. For the lobby materials, we wanted dark steel supports, exposed concrete floors, and white walls. We want it to feel welcoming and bright while having dark contrast, so we went with dark blue furniture and seating area rugs that match the dark steel. The circular rugs match the entry vestibule and reception desk shape, which has light wood slats to go with the stairs. There's also a center space for STEM or STEAM-inspired art pieces, which could rotate every few months to show off art pieces by different artists.
For our meeting rooms on floor 1, we chose to have 2 separate areas, one of which with a glass wall for more public viewing, but there is a more private setting within that behind a barn door in that same room. In the lower meeting room area, we have many more rooms and much larger tables to accommodate more people. We wanted to go for a very warm and bright tone, so we used light oak and tried to keep mostly bright and natural lighting, but can't always have that. Sometimes you do have to go with more unnatural and LED lights for that.
These are the floor plans for the feature staircase. As seen on the left, the bottom set of stairs has wider steps that double as seating. The staircase wraps around and is repeated onto the second and third floors, except without the seating steps. On either side of the staircase, there's a green wall and elevators. Our inspiration for the staircase came from a couple of different places. The photos on the right show inspiration for form and materials, and on the left is a finalized sketch of what the bottom level of the staircase might look like. For materials, we decided to use glass, steel, concrete, and lighter stained woods, which will carry throughout the building. This is an effort to keep it natural, light, and airy. Examples of what the green wall might look like are also pictured on the bottom left. As for lighting, we decided to go for built-in lighting in the staircase rather than a fixture, with the assumption that most of the light will come from the windows during the day, and additional lighting will only be needed at nighttime. The second level floor plan is for the digital fabrication and the computer labs, which we intentionally left separate from the wet labs. In the center of each floor, there is an open lobby area, and a few walls, which are marked in blue, are glass to encourage interaction between students and guests.
The level 2 and 3 common areas are very similar and match the theme of the lobby. With the dark steel supports, we continued with dark blue furniture, which also reflects Seattle's location right along the Puget Sound and reputation for rain. The seating area is carpeted to keep noise down for the classrooms and labs, but exposed concrete walkways for easy cleanup. The common area is meant to feel clean and more futuristic than the lobby, and the lighting is fairly simple with geometric shapes.
As mentioned before, our labs have glass wall to increase interaction and allow students and visitors to view what is happening inside the digital fabrication labs. As far as materials in the labs, we have opted for wooden desks, white finishes, and concrete floors for simplicity and easy cleaning, especially during COVID. Additionally, the desks will be grouped together to encourage collaboration.
Floor 3 is the wet lab or chemical lab, or however you want to call it. It is the only place that has a outdoor terrace and is connected to that via one of the wet labs and one for public. For the wet lab design, we chose to go for very practical and cleanable areas with very white and bright colors. Just for easier cleaning, as well as a glass wall in one of the classrooms for, again, public viewing and public interaction.
My name is Colin, and I'm the MEP student, and I worked with mentors Heather and Laura. Our building was designed with 3 major mechanical systems in place: energy recovery ventilators, or ERVs, dedicated exhaust fans, and variable refrigerant flow, or VRF. An ERV, as shown below the label, is a piece of outdoor mechanical equipment that supplies the outside air intake and the exhausted air for the building's ventilation system. Additionally, ERVs recover heat from exhausting air and use it to precondition incoming air. Dedicated exhaust fans allow for individual spaces to have an increased level of air exhaust on top of the exhaust already provided by the ERV, which is great for spaces where harmful fumes are commonplace, such as in our wet labs. VRF systems are used to heat and cool buildings and are comprised of 2 main components: condensing units and fan coil units, or FCUs. Condensing units are the outdoor equipment used in VRF systems that conditions the refrigerant used in the system, which is then sent to the FCUs, which are located in each individual space. VRF systems allow for varying degrees of heating and cooling in different spaces within the system, allowing for greater comfort and efficiency. To provide enough ventilation, heating, and cooling to each space in the building, we used information from the floor plan and values from ASHRAE tables such as square footage, wall and window area, and window, as well as wall and window direction, and other space-specific values, which are then input into a program called Trace, which calculates the needed loads. The loads produced by Trace are then used to select the equipment for our systems. When considering strategies for LEED proficiency, we mostly discuss ideas to increase our building's efficiency in both the mechanical and plumbing systems. One method we chose was water-conserving plumbing fixtures, which would reduce the overall water consumption of the building. Next, we decided to use a reclaimed water system, also known as a gray water system, which allows for non-potable water fixtures in the building to source their water by reclaiming used water from other fixtures. Thirdly, we chose to focus on enhanced indoor air quality throughout our mechanical system by increasing the flow of outside air, adding source control fixtures like the snorkel exhaust used in the lab rooms, and adding carbon monoxide monitors throughout the building. When considering strategies for mitigating the spread of COVID-19, we found that the most plausible methods for our building were advanced filtration at the individual room level and increasing the outside airflow through similar methods to what we had planned to enhance the indoor air quality. This here is a conceptual one-line diagram of our mechanical system. The red line indicates the exhaust ducts through an ERV, a blue line represents outside air ducts through an ERV, and the green line represents exhaust through dedicated exhaust fans. Also shown in this one line is the mechanical shaft, which allows for ducting on each floor to make its way to the rooftop equipment. Some things to note are that each floor is broken into its own ventilation and heating systems, which can be shut down individually. We also placed a fan coil unit in each room that would need heating and cooling, and each wet lab was given its own dedicated exhaust fan. This is the level 1 mechanical floor plan. Things to note for all of the mechanical floor plans is that ducting follows the same color scheme as in the one line. Each room needing heating and cooling is given at least one FCU, which is placed to scale with the floor plan, and as much ducting as possible will be left visible for possible educational purposes. This is the level 2 mechanical floor plan. Something to note that's special about this floor is the additional considerations needed to keep rooms like computer labs and digital fabrication labs comfortable while many heat-producing devices are running, such as computers and 3D printers. This is the level 3 mechanical floor plan. On this floor, it should be noted that each of the wet labs is given its own dedicated exhaust fan, just like we showed in the one line. And with each exhaust fan, it's routed directly through the ceiling to the actual exhaust fans on the roof. This is the mechanical roof plan for the building. All the rooftop mechanical equipment is located on the south side of the roof, generally shown to scale, which includes the required service areas. It's important to note that the rooftop dedicated exhaust fans are located as far away from the ERVs as possible to prevent any exhausting fumes from re-entering the ventilation system through the outside air intake.
Hello, I'm Ryan from Landscape Architecture, and my fellow peers are Zach, Solly, and Aiden, with mentorship from PJ, Delina, and Nick. As a team, throughout the whole designing process, we learned what it takes to work together to accomplish a shared goal. This year, we took a look at what makes landscape architecture unique from other disciplines, while also acknowledging the different ways others can affect our planning. Some team priorities for our project was to analyze the surrounding area and determine what would be the best course of action in order to materialize the spaces into a pleasing and livable expanse. Here's a first look at the main frontal plaza. To give you an idea of the functionality and important points of note on the map, the key features are noted on the bulleted list. This image here is exactly what we're proposing to use for the area starting at the main plaza entry and running all the way to the building entrance. This is the finalized planting plan of both the front and rear of the building, but we'll still be focusing on the front portion for now. Scattered around the map, you'll notice the different types of plants that correspond with the symbols on the map next to the images. Going from top left to bottom right, the plant sizes increased. Our goal was to use mostly native plants throughout the site. These are some of the inspirational images that we and mainly me considered for the upper portion of the site. On the top left is the previous pavement to allow rainwater to pass through and filter into the soil. On the top right is what we'd like the recreation lawn space to look like. The bottom left image is an example of what we envision the community garden to be in its finished form. And finally, some concrete steps for one of the roadside entries into the main front plaza.
This is the site plan for the south section of the first floor. There's a bioretention area in the south because that is the lowest area of the site. So water goes down to it. It also connects to water features in other areas, so we get water through there. There is also a path going around the building, which connects to the north section and also connects to paths leaving the site. There is a terrace right outside the entrance, so people can get around out there. Also in a wall, which is the sliding windows and connects inside the break room. This is the planting slide. We wanted to keep a lot of Pacific Northwest plants to make it feel more natural. It's also water retention plants. So those are plants that can grow in water. So we use those in the bioretention area. There's also trees at the entrance to the boardwalk. So we're kind of going for the idea of like if you walk through them and then you come out in like a different area. These are some reference images we use while designing it. So there's like cement paths that are surrounded by plants. There's also Pacific Northwest plants that we use to like represent where we live, and also a bioretention area with a boardwalk with plants growing out around.
This is a site plan for the second floor terrace. The planters would stretch around the perimeter of the terrace and would be about 4 feet wide, and we would have wood floors. There would be a water feature that would stretch through the planters and water the plants. We wanted a game table for games like ping pong, and we would have seating around that and the majority of the terrace. For the planting, we wanted to do native grasses and ferns in the majority of the planter boxes. These would be about 1 and 4 feet tall. We wanted to put a few trees around the perimeter of the terrace that would provide more privacy. These would be about 20 feet tall. These are some sample images of what we wanted the terrace to look like. We wanted to have wood flooring and planters surrounding the majority of the terrace and lots of tables and seating. There would be a few outdoor couches and many tables for people to work and study.
And so this is our roof deck plan. We had a little more space to work with, so we took a little bit of creative liberties. We decided to make a little bit of a larger planting bed there as 5, as well as a bench on the entire area to increase the community feel of it, as well as we added some tables and chairs under the beautiful ribbon designed by our architecture team. And we do have a viewing area shown as 4 for retaining that nice view of the Space Needle, as well as a similar tree screen along the right side. And so this is the planting plan. We have a few different sizes here. Because of our larger planting space, we did want to kind of maximize on that. And so shown over on the right side is our larger ones for the green screen, as well as the central planting area, and then some ground cover like Salal, just for the standard plants. So these were again some precedent images that we liked. We really did like the idea of kind of an integrated planting area with the seating and the entire space. as well as a more naturalistic feeling, as the interior design team and architect team stated. We did like kind of to use a little bit more wood than concrete and metal. And we also really wanted a community space for people to relax and engage with each other.
Hello, my name is Sammy, and my partner is Noah, and our leaders are JB, Charlie, and Max. This is construction management. In this presentation, we're going to be going over the safety, the logistics plan, the work breakdown structure, the estimate, and the value engineering options, and the schedule. So, so all of our workers will be wearing hard hats and glasses and vests for visibility purposes, and boots and hand protection at all times. For our safety on the job site, we're going to have overhead protection for people walking by along the street. We're going to have fences and gates around the whole border, making sure that it's safe for people that are in that area to walk around. And our crane, we made sure that it has a safe, we put it in an area so it can rotate 360 degrees without any problems or without it running into anything. And for our haul route, we made sure that we found the ways that were the most convenient for trucks that are going to be handling supplies and bringing things in and out of our job site. So we found the most convenient way to go in and out from our job site.
So our work breakdown structure was an overview of the materials we would need to complete the building. So it went down in order, basically similar to the estimate that will be later in the presentation. This labels most of the estimates so that it's most of the estimates. So it's most of the estimates. So this is the overview of basically the estimate. Our price estimate from the outline that we took, we saw that it would be around 30,300 square feet, and we estimated that it would, by the end, including fees and insurance, it would be around $630 a square foot, which would equal out to just under $19 million, which is fairly over budget. So our estimate, we basically took the outline of the interior design and took numbers that were used in previous buildings to estimate the price per square foot or per unit. And just to note one, windows, we estimated that would take 8.25% of the whole budget, which would be just under $1.4 million. So that was the most significant piece of material off of the budget. And then this is the remainder of the budget. We just did the exact same thing. I would like to note that lab equipment was about 3%. So we gave it an allowance of $500,000 because we were not sure exactly how much we would need. So we gave $500,000 in the budget. So we wouldn't go even more over budget. VE items, we saw that there were garage doors on the 3rd floor balcony, and we didn't see a reason to have garage doors. We thought that sliding glass doors would be a little more cheap because we are significantly over budgeted. So we would subtract $55,000 from the budget. And then there were 2 elevators going to the 3rd floor, and we thought that we only needed 1 to go to the top floor. And then also we wanted to note that windows, there are quite a bit of windows, so that is the most of the budget, even more than labor.
And then for our schedule, we kind of split it up into different sections that we're going to be doing at different times or like together. And we put all the different floors into different sections and kind of repeated the same process for all 3 floors. And then, yeah. And that is the end of our presentation. Thank you for listening. Does anyone have any questions?
Okay, nice job, guys. Let's turn it over to the judges, and everyone feel free to write questions in the Q&A box if you'd like. Avra, want to go first?
Sure. First, I would just like to say great job to everyone. I could tell that all disciplines have definitely been coordinated throughout the whole year. It seemed like the group was on the same page for the design throughout the project, which is really inspiring to see, especially during this age of digital communication. One factor or design element I'd like to focus on and hear more about is the ribbon, because I feel like that's really what sets your project apart visually. And I'd like to hear more from the students on how the ribbon became the ribbon and where it was, why it was located where it is on the building. Is it highlighting certain programmatic elements, or yeah, I'd like to hear more from the students about that.
I can jump in here. My name is Anna Ertzgaard. I'm on the architecture team. For the ribbon feature, we took lots of inspiration for the general design of it with the wave structure to it, from our surroundings, lots of water, lots of the Puget Sound is right here. And we decided to put it over the rooftop area of our building where people could have access to, so it could provide structure and shelter to people who are using the roof for its rooftop purposes. And then there was one last thing. Yeah, our rainwater feature, it could have, I think we still need to do some more coordinating on the rainwater feature itself, but we're gonna do a more exposed one so it's more educational, and so that we could incorporate more educational abilities into this feature that we have.
I'm curious, what would you expect the ribbon to be built out of? I thought I saw that you were anticipating it would be concrete.
Yeah, our plan is to do it with concrete.
Did you consider anything else to maybe simplify that, or potentially pull some of the cost out of that?
I would like to, I worked on this, but I know one of my colleagues, Andy, worked on it, was more of an expert, so I will let him speak to this if he can.
Okay, so I think we primarily designed it to be made out of concrete, but I feel like we could have done it out of metal or some type of steel too to reduce the cost.
I can add to this more, and oops, I am Joe Biden. Okay, not Joe Biden. So for the structure of the ribbon, we did want to, so in the structure of the ribbon, we did have put steel bars into it and attachments to it. And we just kind of did that because like the wavy complex of the design, yeah, so we simplified it a bit into like a basic plan. And we thought steel into the concrete, which is AKA reinforced steel, would be better just to like hold up the ribbon with the attachments along with that better too, but to also to deal with like moment capacity, which is what the ribbon will have to stress about. So that's what we kind of did with the ribbon.
And to your contractor team, did you consider the costs for that ribbon?
The costs we did not, but we kind of just relied on construction, to be honest.
I'm Noah. I was on the GC team. We did notice that metal had a lot of custom outcut or cuttings in it. So, and it was one giant piece of metal, so we knew it would be expensive. Probably should have noted that a little earlier, but it's a little too late to do that now. But yeah, that was pretty expensive.
Yeah, so I could see, maybe from the owner's side, it would be something that as you iterated through design, it would be, you'd really want to consider some alternatives there. And it might be that what you've chosen is really the best alternative. But you probably want to end up, looking at steel or looking at something that was more of a kind of cladding type of element that might allow you to reduce some cost and potentially either reduce the project cost as a whole or allow you to put some of those dollars elsewhere into the project. It's an amazing feature. I think it really adds so much, something very distinct to the building. But I think as you go to implement something like that, there's a secondary effort to figure out what's the right size, what's the right cost, how to best implement it so that it gets you what you need and what you want in the most appropriate and cost-effective way.
Yeah, good point, Stan. I'm like, can everybody hear me? It seemed like my internet was going in and out. Gotcha. So I just want to commend the students on this great presentation. Just hearing all the attention to detail for especially each discipline was great to hear. I could definitely tell the mentors had a great hand in helping the students kind of understand how things would come together and how an integrated team would work together. So I guess my first question would be to the architectural team. What was the inspiration for your form of the building and then the inspiration of the ribbon itself?
I can talk about this. So, sorry, my name is Henry. I was part of the architectural team. And as Anna said with the ribbon, we kind of, as well as looking at the Pacific Northwest aspects, so like water and such, we also looked at the nearby building, the Mopop, which was built by Frank Geary, which has a similar architectural style to the ribbon. And could you repeat the second piece of that question? Sorry, I misheard.
Yeah, no worries. I was just wondering what the inspiration of the building and the ribbon. So you told me the inspiration of the ribbon form, but what was the inspiration of the building form? And why did you cite the building the way you did?
Oh, so for siting, we wanted to position it farther away from the Space Needle because we didn't want to create too much cross traffic because obviously the Space Needle, it's a pretty touristy place and you get a lot of people coming in who may not be familiar with the area, so you don't want to create too much confusion. And for the actual building, we wanted to create something that was low lying. and didn't go up too high. So that was kind of why we decided to keep it under 3 stories. And that's sort of how keeping like a rooftop terrace to add a 4th story, but not make the building go up too high that was kind of the thought process behind that.
Gotcha. Yeah, going back to one of your goals of taking a look at, you know, the inspiration of being creative and bringing the STEM idea, I was wondering if there was a way to maybe connect to the museum, the Pacific Science Museum. So it'd be easier for you to just have quick field trips over there. Like you can have your class over at the museum as opposed to actually within the building.
I'm sorry, was there someone going to respond to that question about the adjacent building, or I'm sorry, I missed something. Okay.
Yeah, I don't think so.
Okay, I'll take up from there then. I didn't want to interrupt someone. So to the structural engineer, what do you think the biggest challenge was for your engineering design?
I think to us that will be the ribbon, because like trying to design the structure of the ribbon was kind of difficult because like all the complex curves, like, you know, the ribbon, the curvy things, and just like trying to like make the concrete into that shape and like design how to hold it up was kind of difficult. So like in order to like just try apply it to like the overall ribbon, we just really want to like find how to analyze the structure of it. So like we just made a complex basic plan that just goes around the ribbon, like the side roof plan, and then we design, and then like to find how the structure of the ribbon will be, we just took a portion of it from attachment point to attachment point, and then we kind of designed like how those steel bars would be integrated into the ribbon section. And by doing on that one section, we applied it throughout the whole plan, and that's how we kind of made the structure. That's how like that would like be like the hardest component of this structural part, I guess. But yeah.
And I guess a similar question for the mechanical. What was the hardest part for your mechanical design?
Yeah, I think the hardest part for a mechanical design was definitely having to figure out a place that settled well for all of our rooftop equipment. Because with a rooftop that was planning to be occupied, you have to find a place that for the rooftop equipment that is both functional and hopefully safe and aesthetic as well. And so that was probably the most difficult part.
So I have a question for the structural and the MEP teams. Was there any type of consideration of maybe expressing those systems more openly, having them more exposed, and maybe having like your structural tension minimums being a different color versus your compression or your tension and compression being different colors?
In regards to MEP, I know we planned to leave many of our ducting exposed. I don't know that we had considered color coding them visually with that exposure, although I think that would be a very interesting idea and be great for educational purposes.
Personally, for us, we didn't really consider that. We just wanted to focus on the structure. Yeah, just we didn't think of like these. I mean, when imagining the ribbon structure in my head, we will have the attachment bars from the ribbon to the building kind of a bit exposed. So I guess we could have colored that, but that is a nice thought.
one of the team's goals stated at the beginning of the presentation was integration with the campus and the public. So I'm wondering how the team, specifically the landscape team and the interior architecture team, balance public interaction with private student areas, and especially considering integrating any safety that the students need to have while they're in school.
I can answer this question. My name is Ada Franey, and I'm part of the interiors team. As far as safety goes, I did a lot of, or my team in particular, but we did a lot of work designing the staircase in a way that wasn't too centrally located so that the public would stay mostly on the first floor for safety reasons, just to not have a whole bunch of strangers walking up and down the staircase with the students. But we did want to completely eliminate the idea of having interaction with the public. So we incorporated on the labs those glass doors and glass walls so that if people were, supposed to be there watching and looking at what the students were doing in the labs, they could see through those walls and yeah, just get a peek at the inside, like inner workings. And so I think it was kind of tough to balance the two, like safety and also community like collaboration, but I think that we tried our best to walk that line.
Let's have the judges do one last kind of summary of your thoughts and impressions, and then we'll move on to our second presentation. So let's go through one by one. So Leon, why don't you go first?
Yep, sounds good. Like I said early on, I just want to commend the students on this great presentation. Just hearing the different disciplines talk about the aspects that they were basically in control of, and basically how they were able to integrate into the design of the whole building was great and refreshing to hear. I was deeply disappointed to see there's VE, especially for this type of project, because I have to deal with VE, and it's like, you guys don't need to deal with that. But it was just great to be able to see everybody, all the students dive into their aspects and just, have fun with it. So it was a great presentation. Thanks for the presentation.
Thanks, Leon. Avra?
Yeah, I just want to say great job to all the students again. I think I've met with you 2 times throughout this school year, and every time I've been more impressed with how coordinated and integrated all the disciplines have been. So great job. I would kind of counter what Leon said and urge the team to consider cost while they're designing, because there was a budget of, I think, $12 million for the project. And as the construction team noted, we're a little bit above that. So yes, this is a fun and educational project, but also we're trying to integrate some real world experience into this. So keep that in mind, that a future in architecture will include VE. But that being said, great job to everyone, and you guys all have bright futures ahead of you.
Dan?
Yeah, I would say, it's always just amazing to see these presentations. I think everyone did just an incredible job. The presentation was so well done. The thing that I was really noting throughout the presentation is that there were very few words on most of the slides, and that's a good thing. And there are professionals throughout the world, and I've made that mistake myself, where I have put too many words on slides and given a presentation, and it's just not effective. So I think everyone did a great job. I think the presentation was great. It's apparent that a lot of hard work and effort went into this, and it is a learning thing, right? I mean, this is something that professionals with many years of experience struggle with, how to get through a project. So I think everyone should really be proud of what they accomplished, and what you presented here tonight, in both how you presented it and what you presented. So just kind of the things that jumped out at me as I was observing and listening.
All right, thank you. Great job, Wednesday Team 1 with GGLO. Let's move on to Wednesday Team 2. I'd like to introduce you to Casey Risky with Miller Hole Partnership. He is the team leader. Casey holds the record, I think, for the longest running ACE mentor. If I had done my homework, I would be prepared. I feel like it's like 12 or 13 years or something. Maybe Casey can chime in. He's also received an Outstanding ACE Mentor Award at the national level. Each year they choose only 5 mentors around the entire country, and Casey won that award. I think it was 2018, if I'm correct. But again, I should have done more homework before coming to the call today. Casey, do you want to say a couple of things, and we'll start your recording?
Sure. Yep. It was. This is year 14 for me, and it was 2018. Good memory, Angela. Great job, Wednesday Team 1. This was a fantastic project. Very interesting, very detailed. The graphics on the hand drawings were fantastic. I was totally blown away. I want to thank our ACE team for working through this difficult year and maintaining with it, sticking with it, working all the way through. Special shout out to all the mentors for working with all the students and making it happen and keeping it really going. Our project turned out really good. It's full steam ahead. Let it rip.
We'll get there.
Hi, welcome to the final presentation of Full STEM Head for the Wednesday Team 2. My name is Juana. I'm a current senior.
And this is our team. These are the students, and we're from Roosevelt, Ingraham, Archbishop, Murphy High School, Sammamish High School, and Rainier Beach High School. Okay, so this is our RFP, and so we had a STEAM class, technology classroom that had to be a public campus, and we also needed to include some sustainability elements as well.
This is the site analysis. I'm Meraki. I'm a junior at Archbishop Murphy, and this is my first year at ACE.
And I'm Anna, and I'm a senior at Roosevelt, and this is my 3rd year in ACE.
This is the location for our project, and it's in Quinn, Seattle on Broad Street. On this slide, you can see other buildings that surround our current site, like the Space Needle, the Pacific Science Center, and the IMAX Theater. These are existing exterior patterns and textures of the buildings that surround our project site.
This is an example of the things we did for the site analysis. We looked at where traffic would be, where people's pedestrians pathways would most likely be, the areas surrounding our site, such as the rest of Seattle Center. And we used different group collaboration strategies for this.
This is the architectural design section. I'm Sarah. I'm a junior at Roosevelt High School, and this is my first year at ACE.
My name is Braden Durago. I'm a senior at Roosevelt High School. This is my 3rd year in ACE.
I'm Skylar from Roosevelt High School, and this is my 3rd year at ACE.
I'm Lease. I'm a junior at Archbishop Murphy. This is my 3rd year in ACE. I'm Rushkan, and this is my first year at ACE. And I am from Rainier Beach High School.
I'm Aryan, and I go to Roosevelt High School, and this is my 2nd year of ACE.
Hi, my name is Eleni. I'm a senior. I come from
Bellevue, and I go to Sammamish High School.
So when we started our project, we had some initial inspiration in mind. So we had a couple ideas for what features we wanted. So we wanted an indoor relaxed water feature. Well, we wanted an exterior terrace on the second floor. We wanted some open small meeting rooms, but we also wanted to utilize big open glass windows. We wanted to have a flexible lab space, multi-purpose staircase, and we wanted to utilize bright yet simple colors. So you can see some of the inspiration images we had. We're kind of utilizing that natural theme while still staying modern and light, and then again using those bright but simple colors.
This is the exterior material palette. We chose to use mass timber for sustainability. The exterior brick contrasts with the metal siding with their different textures and colors. Our building will have large windows with frosted glass, which will provide enough light while keeping privacy limiting.
So to start off the architectural design process, we started by making partie diagrams and sketching out our ideas. So along the right here, you can kind of see some initial sketches we had for how we wanted the building to look. And then as we kind of progressed through the design process, we moved down to some more advanced diagrams like you can see in the bottom right that kind of give us a little bit more of an advanced idea of what the building was going to look like. And we also utilized like satellite imagery to kind of give like a bird's eye view of where we wanted things to be placed throughout the site. So as we move further in the design process, we moved into more plans, and we also developed sections to develop design further. Along the right side here, you can see kind of a little bit more of an advanced plan here where things are going to be throughout the building, those kind of some initial ideas. And then along the left, you can see a section that we made kind of shows where things are going to be as well. Things like the meeting room, the wet labs, the outdoor terrace space, and things like that. So here's our site plan. Again, as we went throughout the design process, we continued to develop this, and this is our final design. So a couple things about this. So the primary entry into our structure is going to be from the northeast via the roundabout in front of the Space Needle. And then along the left there, you can see we're having a solar panel flower structure in the lawn, which is not only going to kind of add to the theme of the building, but it's also going to help us with power as well. So here's our level 1 floor plan. There's a couple important aspects to it. So we have a monumental staircase in the lobby that's providing access to the courtyard on level 2. The hallway is designed in a loop that's going to provide continuous circulation and ensure that when you're in the building, you're not feeling trapped or stuck anywhere. Those central meeting rooms that you see in the middle, they're made up of glass along the outside that's going to promote transparency and collaboration amongst the people who are in it. And then the restrooms are also located in the south corner. That's going to prioritize making sure people don't have to walk super far to go to the restroom, make sure everybody who's using the building is able to get access to it. As for the second level floor plan, there's also a couple important things. So again, that main staircase is going to provide open access to the second level, and the atrium is also going to bring in daylight to kind of, again, light up that building, give it that kind of light and airy feel. That admin office in the top right there is going to be made pretty prominent, and it's going to take advantage of the view with the glass walls that's sitting right in front of that roundabout next to the Space Needle. So we're going to take advantage of that view. And then again, similar to below, the U-shaped circulation, not only does it provide 2 access points to the outdoor terrace that you see along the left, it's again going to make sure that you don't feel stuck when you're walking throughout the building and that you can get where you need to go.
We started modeling our building after the architecture team finalized the floor plan design. And on this slide, you can see several snapshots of our Revit model before any detailed renderings.
We started modeling our building after the architecture team finalized the floor plans. Right now in our model, we have an exterior that is pretty much all glass. There's also room for us to design a more intricate roof instead of just a flat roof. We used the program Lumion to create renders and also added scale figures along with textures. The 2 photos on the right are of the terrace off the second floor, and we added native plants to make the space feel more inviting and a fun hangout space for people to enjoy.
These are the exterior choices that we made and the local plantings. There are also drop-off sequence and building entry and location on site.
As you can see, this is how the building looks from the front. And have the two windows for the lab room and computer room. And over there we have like partially shading over the windows, which helps to balance out the sunlight. We continue native plants that wrap around the building, and the use of large windows both on the first and second floor allow for lots of light to flow in and allow people from the street to view into the lab spaces and for the students to view out.
This slide talks about the daylight study and computer lab. And on the left, we have our computer lab video showing us that the computer lab actually faces the southeast of the building, and our sunlight comes in June 2nd. The sunlight comes on from the west to the east, and some of the shade that we can see on the left side, it can shade some of the sunlight coming in. In the video, you can see that you can see half of the building is a lot darker than the rest. And that's it.
This is the interior design part of our project. So these are some images of inspiration that we took for our building. As you can see, we wanted an indoor relaxing water feature, flexible, flat, multi-purpose stairs, and bright yet simple colors. These are the murals we looked at for the lobby. The one on the left is abstract and celebrates women in science, while the other one is more realistic and focuses on nature.
So here's our furniture plan for the first floor. When designing this, we were very deliberate in the placement of all the different furniture elements. We wanted to, again, make sure that each space was serving its purpose and that nothing was, unnecessary getting in the way. Along the right, you can see some inspiration images we had. You can see what we thought in the meeting room, the lobby, and the Digifab labs. That's kind of the inspiration images, what we thought it would look like in the actual building. And then similarly for the second level furniture plan, again, with the admin offices, the computer labs, and the meeting room, we're placing these things very deliberately to make sure that we get the most functionality out of these spaces and that, nothing's getting in the way of what people need to do. And then again, on the right, you can see some inspiration images for what we thought the computer lab and the admin office are going to look like, kind of staying with that modern, open, kind of light and airy feel as well.
In the lobby, we have a sitting area by the entrance and the reception desk in the back by the stairs. We are mostly using warm tones in the furniture to contrast with the blue mural that we saw a few slides back.
This is how the blue mural is gonna look on the wall that's behind the reception desk. As you can see, the lobby room has floor-to-ceiling windows and a circular staircase, which is efficient for spacing.
For the admin offices, we're using toned down colors that aren't overwhelming but provide a pop of color. The furniture on the top will line the walls in our open office. The furniture on the bottom will be placed in the middle of the room and are for the meeting areas.
The admin office has the view to the Space Needle, and as you can see, it has large windows and the Versailles is shading over the windows. We also have natural color wood columns inside this room, and as you can see, the inspiration is on the right side.
For the conference rooms, you can see some of the furniture that we picked out.
And on the right, you can see our inspiration photos that we are basing our conference rooms on.
The conference room, we decided to put warm colors on the walls and ceilings. There are natural light in the room and some wood tables to add a natural feelings.
The meeting room also has the columns that we saw in previous rooms. It has a large desk, natural and tall, and a good view, and it has a large windows. And the image that we got inspired by on the right side.
This is the digital fabrication lab. On the left, you can see our floor plans and furniture that we picked out for this space. And on the right, you can see some of inspiration photos of what we want our digital fabrication lab to look like. And above that, we have the rendering of our digital fabrication lab.
The digital lab of the computer lab offers a large window, which is covered by diverse leaves and natural wood columns. And those like a very modern lighting fixture, and the inspiration came from the images on the right. Hi, I'm Abby Johnson. I'm a freshman at Sammamish High School, and this is my first year at ACE, and this is the beginning of the landscape design section.
My name is Ella Mansfield. I'm a junior at Roosevelt High School, and this is my second year at ACE.
This is the view of the terrace. We added scale figures, textures, and plants to make the space feel more realistic.
We also considered plantings that were good for pollinators like honeybees and butterflies, and these are a couple of the examples that we looked at.
These are the plantings we decided that would be on the terrace courtyard area. We have all native species, which will increase water efficiency, which was very important to us. The honeysuckle vines will shield the mechanical yard, so it won't be as much of a distraction if you were to work outside. And we chose trees that had short growing and shallow rooting, so then they wouldn't be as much of an obstacle if they were to fall over.
Here is our terrace plan and design. The terrace has a loop path around the fountain with smaller paths connecting to tables. We wanted to make the terrace accessible for all students, whether they wanted a quiet place to work, talk with a friend, or eat with a group of people. The trees and plants are placed to provide a sense of privacy from the glass windows of classes that are along the east side of the terrace. The trees are also placed for shade around benches and to create separation between different study areas. With a great access to the scenery around the terrace, we made sure that the view is accessible by adding some paths along the rim, along with benches to provide a relaxing place to sit. Here's our fountain design. The bowls pictured are stacked in the middle of the fountain, and the water is flowing from one bowl to another in a spiral shape into the bigger pool of water. There's a drop between the bowls and the pool, and this will allow room for a living rock wall, which will give an organic feel to the area. The pool creates a natural and calm setting for students to study, talk, and enjoy the outdoor scenery.
These are the plantings we chose for the exterior of the building. These are all native species except for the ornamental cherry tree, and we chose a mix of shade tolerant and drought tolerant shrubs and ground covers that would withstand the weather patterns of the area. This is our planting plan. We will have trees inviting people into the building near the front, all lined up. And the different zones are based on the amount of shade in each area. For example, zone B will be getting the least amount of sunlight, so they will have the most plants that don't require a lot of sun, as opposed to zone C, where we have trees placed in order to shade some of the natural sun from the incoming windows. We have the grass area with cedar trees because they have room to grow there, and it will be also used as an area to lounge or a outside experiments area.
This is structural engineering. My name is Luke Johnson. I am a junior at Roosevelt High School, and this is my second year in ACE.
My name is Riley. I go to Sammamish High School and I'm a junior, and this is my first year in ACE.
There are two primary types of loads, vertical loads and horizontal loads. Vertical loads can be separated further into live, dead, and environmental loads. A live load is something that can move throughout the building, whether it be a person, chair, or a computer. A dead load is something that will stay in its intended position, like a desk or a wall. An environmental load is a load that is put on the building due to the environment. This could be leaves in the fall or snow in the winter. A horizontal load is something that affects the building laterally. This can include wind that can cause the building to shift and earthquakes that can cause the building to sway back and forth. The floor, which is made from slabs, are the main bearers of weight because almost all of the load is directly applied to them. They are the foundation of the stories that are not directly on the ground. Beams are the structural components that transfer the load that is coming from either the story or the ceiling above. Columns are the structural components that help bring the load from either the upper floors or the roof down to the foundation below. The foundation is a structural component that helps distribute the load from the building into the ground below. There are many primary building materials that are used throughout construction. The main three are steel, reinforced concrete, and wood, and they all have their strengths and weaknesses. Some are better in different situations because of their ability to bend, while others might be bad because they're susceptible to wear from outside sources.
So we have two systems. There's a gravity system and a lateral system. A gravity system is strong foundations with columns and beams, and that's acting against a gravity force, which is gravity pulling on the building. And then we have our lateral systems, which will act as support for the sides of the floor and are in charge of limiting or minimizing the amount of movement. And they act against wind forces, which put pressure on the front side and section on the back side, and seismic forces, which shakes the building at the base. And since we live in Seattle, we tend to focus more on the seismic forces. And here we have beam behavior. We have three. There's bending, which is supporting the load at the top and will deflect downwards and experience internal curvature. Then we have shear, which is cutting or slicing through something, like cutting through a piece of fruit or cheese. And this cannot be avoided, but we can limit it. And then we have deflection, which is also inevitable, but we want to keep the amount minimal. Here we have column behavior. And compression is when a column is short enough, pressing or pushing with a high force will lead to crushing failure. And we have buckling or bracing, which is when a column is long enough, pressing on it will bend it out of the plane. And 2 points between which a column buckles is called a brace point. And the further away the brace points are, the more likely the beam or column will to bend. Here we have our foundation types, and we have shallow foundations, which are platforms at the base of columns as a way to reduce stress on the soil by spreading and distributing the weight over a larger area. This is very important to this build. And then we have continuous foundations, which fall along the bases of walls, and mat foundations, which are large spread footings that support multiple walls or elements.
The primary design for our beams had to account for the 15-foot cantilever that was asked of us. This beam had to be strong enough to support not only its own weight and the weight of the roof just above it, but also the moment demand from the roof that it's attached to. To make this work, it needed to be able to bend more than it would under the stress from the rest of the structure. We chose to construct it out of wood to match the aesthetic of the rest of the building. And due to this, the beam had to be about 1.3 to 2.5 feet in dimension. Columns are used to support the weight of the floors or roofs above them, and so they need to be strong in order for the building not to collapse. A column's length and width are determined by how much forces they can hold up. They need to be able to support the whole floor above them, as well as the vertical force applied to them from the beams. We designed 2 different columns because there is a difference in the weight of the upper floors depending on where you are in the building. All the load from the structure needs to get transferred to the ground. This can be done by spreading the load over a big area on the ground. The area that is needed to enable a safe transfer depends on the amount of the load that is wanted to be transferred and the capacity of the soil that the building is resting on. We made 2 different size foundations that will hold up the building. They'll be embedded into the ground and made from solid concrete.
So Seattle is in an area with many potentially active faults and is also in an area with medium to high shaking hazard. And we need to take this into account when designing beams and columns within our buildings. If we underperform with our supports, it could lead the building to failure and cause more damage and potential casualties. And if we build the way we need to with enough support, then we can limit this. So here's our basic seismic design, and this is kind of a tie-in to our lateral system with the support on the sides of the floor to minimize the movement. And to resist an earthquake, we designed the building to have window brackets around the middle of each wall on both floors, as you can see in red. And we also designed the building to be able to endure shaking from any side, as an earthquake and seismic movement can happen in any direction.
This is the start of the mechanical electrical design section of the PowerPoint. And I'm Anna.
This is our mechanical system. Our equipment is dedicated to the outdoor air system. It's a 25-ton piece of equipment. We're using variable air volume. We really wanted to expose the ductwork and conduit to integrate with our architecture and our overall lab design. And with the light fixtures, we wanted to really incorporate our solar design is off of the Pacific Science Center, so we can use energy, so we don't take any from our environment, and we can get it straight from the sun.
So for the lighting design, we went with a local company that sources materials here in Seattle and the surrounding area. And so we have general shapes for certain areas. And we also wanted to kind of reference the Chihuly Museum with this chandelier that we were going to use in the lobby. And as far as the different lighting fixtures, again, you saw these on the last slide, but a lot of them are simple geometric shapes. We have the hexagons at the top, and these all correspond with different symbols that you'll see in the next couple of slides on the plans. And as far as lighting control, we have implemented occupancy and daylight sensors to maximize our efficiency. And also lighting will dim according to how much light is coming in from the windows. And that will also maximize our efficiency. This is the level 1 reflected ceiling plan. As you can see, there's the hexagons more in the classrooms. We only use the hexagon shaped lights in the classroom spaces, and then the other spaces that are more public or the administration spaces, we use the simpler rectangle circles or can lights. This is the second floor reflected ceiling plan, another further example of the hexagons in this classroom space on the bottom, and then in the middle and top, there's more of the admin and public spaces, which is where we have can lights and the rectangular lighting. And this is our LEED scorecard. We put our building through the all the qualifications, and we came out with LEED Platinum for our building. As you can see, energy and atmosphere take up the most amount of points that our building got, and the rest of the categories, you can see different point ranges for our building.
I'm Skylar, and the last portion of our presentation covers construction management. So during ACE, we participated in a team planning activity where we organized digital sticky notes on a mirror board, and this activity introduced us to scheduling logic. For our schedule milestones, we have planned for the design process to take 8 months and the construction duration to be 11 months. Some key dates include May 1st, 2022, which is when we obtain the notice to proceed. Building dry-in occurs in September of 2022, and the building obtains its certificate of occupancy in April of 2023. This is the spreadsheet for the full schedule. As you can see, many of the activities overlap each other in order to maximize efficiency. The site plan features a rough terrain crane with a working radius of 122 feet. The truck staging and material placement is located in the middle of the site, with the power station, portable bathrooms, office, and storage containers located on the southwest portion of the site. We have planned for 2 approaches to our site for material transportation, one route from the north and one from the south. Both routes divert off of I-5 and lead to the truck staging area on the construction site. We also discussed several different value engineering options for our building. Our main value engineering feature was the change from a glass curtain wall system to individual windows on the exterior of the building. Our glazing system was estimated to be $100 per square foot, but our value engineering option reduced that price to $75 per square foot, allowing us to save $200,000 from the budget. To determine the price estimate, we went through a price analysis exercise where we broke down various components of our building, such as electrical, landscaping, and finishes. The table on this slide illustrates the pricing exercise we went through. The total cost of this project is estimated to be $8.4 million. This estimation includes money set aside for contingency. And our total budget was $12 million, so our project falls well below the budget. Thank you for listening to our presentation. And are there any questions?
Okay, great job, Wednesday team 2. Let's turn it over to the judges.
I guess my first question is, when can you guys start on this project? Because you guys are hired.
$8 million, that's great.
Great presentation. I'm sure the mentors had some major help on that, right? But I guess my first question would be to the architectural team. Were you guys involved in the LEED process, or was that just MEP?
I can take that one. So for the most part, it was, I think it was actually a mix of both, because we wanted to consider like a lot of like kind of the passive heating design of like a lot of window light and natural lighting with trying to improve energy efficiency. But obviously like the solar panel array, like located off site, that was definitely MEP. And so it was definitely a mix of both. And then also with like our design of the terrace, that was a mix of, that was more honestly a mix of like, obviously the landscape architecture and the architecture team. So yeah, we were involved both in that process.
So with the solar panel being located off site, what would that mean to the owner to have to maintain that and get access to maintain that? Is that something that was discussed about how there might be some added challenges associated with that?
I guess I can take this one as well. I focus more on lighting design, so I didn't focus as much on the solar panel section. So if somebody else has more details on this that they can add, that would be great. But I wasn't a part of any conversations that we're talking about, like challenges with that being offsite. So there could have been, I'm not entirely sure, but that's definitely true. There would be added challenges with that. And like, obviously we would have to work out something with the Pacific Science Center to have like agreements on like maintenance and everything.
I was also curious about the terrace. What's the size of the terrace? Is there someone who can help me with that one? Maybe the landscaping team?
I'm not entirely sure what it ended up coming out to be, but I know in the earlier stages, at least the set along the road was about, I think, 21 feet long. So.
And is that, I couldn't completely tell. Is that on top of the structure or is that at ground level?
Yeah, it's on the second floor. The second floor isn't like completely over the first one. It lays on top of the first floor.
So for the structural engineers, what do you think the challenges would be for putting the terrace on an elevated floor like that?
I can answer this one. So as I'd said in the presentation, we had to design two completely different columns just because of the different weight values of the terrace compared to another floor of the building. And that just added in more calculations and also more design within the project.
And was it built on timber structure?
Yes, the primary column support system within the building is timber.
So with a terrace on the timber structure, would there be something as an owner that we would need to point out in terms of maintenance that you could think of?
We did not directly talk about maintenance on the columns, but I would assume that it would require probably checkups and maintenance decently often.
I was also curious about LEED. I saw that the design was for LEED Platinum. The RFP was for LEED Gold. Is that adding more cost for the owner, do you think?
I guess I can take this one. So I don't think we talked directly about kind of comparing those costs, but as a lot of like sustainable design within buildings are often more expensive. I would imagine that would increase our costs a little bit, but at the same time, some of the things that we tried to implement, like I mentioned, kind of like the passive solar heating and with use of natural lighting, more of that lighting, we tried to those strategies for sustainable design aren't quite as money intensive, and so I think to answer your question, like yes, I would imagine that increase in the LEED certification probably did increase our costs, but that the estimate of like LEED certification was a general estimate, so some of those things might have not been as specific as they could have been.
I can also add on to that. So in the construction group, we talked about value engineering,
And that was basically, what can we do to various components within the building that will reduce the costs, but also at the same time, we're adding more benefits to the clients and to the residents of the building. And for sustainable elements, obviously, the upfront cost will generally increase. Solar panels aren't cheap, but what we're basically doing is selling the client on the long-term benefits of adding these elements. And I think as a team, we did a really good job of taking account into value engineering and putting our money towards the sustainable parts of our project. And we came under budget, $4 million, so that was really good. And yeah.
Yeah, no, that's great. And I don't want to monopolize all the time, but one more question for you. Why do you think what was it? Maybe it was a bunch of things, but what do you think really drove being able to get the cost so far under budget?
Well, first of all, we had the value engineering component. So one of our main value engineering aspects was taking out the long glass curtain walls that we had originally, and we installed individual windows. We didn't feel like the long glass curtain walls were benefiting the occupants of the building as much. There was privacy issues, and basically everything, it drove the costs up without any large benefits on the occupants of the building. So we took that out. So throughout the project, we were just really conscious of what we were spending, what components we were putting into our building, and we were basically analyzing each component and thinking about if it was actually worth while to install them. And obviously we had the client in mind, but mostly we were focused on the occupants of the building, the students that will be using our education center.
I love hearing about that coordination that's been happening between the construction team and all the other disciplines. That's really awesome to hear. Question for the architecture team. Could you provide some background or insight into how the form of the building was created and where it's situated on site, and specifically locating the rooftop terrace kind of on the back half of the building versus the front half?
I can talk about this a little bit. So initially, when we were kind of planning out where we wanted it to be on the site, we went through a couple different design iterations. Some that was had this building shifted more to the left, some that had it shifted more to the right. And I think we just eventually settled on this specific both building like design and orientation within the site to kind of take advantage of that little bit more of like open, I guess we would call it a little more natural green space along the left side. That's where like the solar panel flower is. So we wanted to have that as kind of like almost a little bit of a buffer space versus with the side that's facing, you know, more the roundabout. We wanted to have that be a little bit more, you know, you face that side from inside of the building. So with the outdoor terrace, as you mentioned, we had that pointing to the left because I believe that there's like a little sculpture there along the left side, and you can kind of see the street from there as well. So not only can you, you know, look to your right a little bit, see kind of that sculpture and the Space Needle above you, but you can look out more onto the street and kind of get a panoramic view.
I have a question for the landscape team. So in your presentation, you talked about using native plants, but you decided to go with a cherry tree as well. Was there any inspiration for using a cherry tree?
We wanted to just have it match the like heights of the other, like the maple trees, the vine maple trees around, and the cherry trees were aesthetically pleasing, and we feel like it would fit the general area.
Okay, why don't we have our judges do their last, some comments and some feedback for the teams, and then I've got a few more slides and we'll wrap up for tonight. Let's see who, Dan, we'll have you go first.
Yeah, great. So, again, excellent work. I mean, it was obvious that there was a lot of team work going on and discussion and coordination, and everyone was really kind of working together. It seems like from what I can tell from the presentation, the fact that, you were able to do your design while also kind of keeping an eye on the budget and thinking about, the students and the owner and everything that really goes along with a real project, really kind of jumps out here. And again, I think everyone did just an amazing job.
I'll jump on next. Yeah, great presentation. I was blown away by the detail that every discipline went into, whether it be the layout of the architecture floor plans and really maximizing the use of space, to the detail in the lighting of the reflected ceiling plans, to the construction schedule and the estimate. Every single discipline really came prepared and had the appropriate detail provided to give us a fulfilling presentation. So great work, everyone, and outstanding job.
Agreed. And I echo the same sentiments. The presentation was top notch. And the way that each discipline was able to take the design theme and basically run that through their individual parts was excellent. So now you guys just have the hard part of actually realizing this project for $4 million under budget. So good luck. But great presentation.
Okay. Thank you, judges. Great job, Wednesday team 2. The designs were really impressive. Of course, every year this event and the innovation that the students tap into is just so inspiring. There's no doubt the future of the built environment is in good hands. I wish we could give everyone a round of applause, right? Should we just kind of, okay, a round of applause. You can do that in our respective homes. Thank you for joining us tonight. So before we go, just a short invitation from ACE. Putting together a program like this takes a tremendous amount of time and energy and dedication. We've estimated that we run a $1 million a year program. While the majority of the program is donated by mentor volunteers and corporate time, we do incur costs like liability insurance and background checks, et cetera, et cetera. We welcome a tax deductible donation to the ACE mentor program if you feel so inclined. So that we can continue to offer ACE at no cost to the students. There's a donation page in the program tonight that was emailed out earlier. But the point of this tonight is just to congratulate all of the teams, and we're so glad that we could celebrate their success together tonight. Lastly, I just want to offer a special thank you to OAC Services for being our webinar hosts, our technology gurus tonight. Ethel, Ari, Cynthia, Christine, we could not have done this without you. So thank you, thank you, thank you. We are recording this and we'll place it on YouTube later. So be sure to check our YouTube page and you can send it to anyone that couldn't make it tonight. And with that, thank you for coming, and we will see you next year. So that is all. Thank you for coming.
Thanks, everyone.
Bye-bye.